Welcome back. Myself Dr. Sayanti Chatterjee, Associate Professor of Department of Electrical and Electronics Engineering, and today I am going to tell about the electrostatic field and different type of charge density. So before starting, what is the Bloom's taxonomy? So from this chapter, students will be able to use the vector calculus and other mathematical techniques to describe the electromagnetic phenomena. So this is the application type Bloom's taxonomy. The label is the application. So what is electric field? Before starting, we have to discuss what is electric field. Electric field E is defined as the force acting on a test particle divided by the charge of that test particle. Another thing, electric field means if there is one electric path, one charge area is there, the work done to bring one unit positive charge, one unit positive charge from infinity to that location. So electric field is defined to the force acting on a test particle. Force acting on a test particle. So say in this problem, Q is the electric charge and it is working on the plus Q0. So what is the force? According to the Coulomb's law, we know force is equal to Q1 Q2 4 pi epsilon r square from the Coulomb's law, and its direction is AR. So from the Coulomb's law, we can tell about the force. The force between two charges is the maybe attraction or repulsion type, depends on the directly proportional to the multiplication or product of the two charges and inversely proportional to the square of the distance or linear distance between them. So what is electric field? Electric field is the force acting on a test particle. So say this is the test particle Q. So what is the force due to the plus Q1? The plus Q1, as this is positive, the force is the repulsion force. So the direction is like this. This is the distance R. This is the distance of the, and this is the direction of the unit vector AR, or we can write only R also. So what is the value? If one is Q, one is Q0, say one is Q, one is Q0. So we got that E is equal to Q0 by 4 pi epsilon R square into R according to the nomenclature. So what, and E is a vector. So what is E? E is equal to force by Q naught. So we can tell force by Q naught. So it will come Q by 4 pi epsilon R square. So this is called the electric field. So what will be its unit? Its unit will be, the unit of force is Newton. So its unit should be Newton per Coulomb. Next we will discuss for a point charge. So what will be the value? KQR square or KQ by R square. And what is electric field then? Already we have discussed this. If force is equal to Q by Q naught divided by 4 pi epsilon 0 R square. So what is the value of the E? So it will be 1 by 4 pi epsilon 0 Q R square, Q by R square, already discussed. So we already discussed that electric field behaves like a vector field. It is not a scalar field. What is the meaning of the vector field? Vector field means it has a certain direction. So electric field is one example of a vector field. A field. What then? The question comes in our mind, what is the meaning of a field? Field may be scalar, may be vector, is defined which is everywhere. Field means if we keep a charge, the area surrounded by the charge where we can experience we can experience some force. So a field is defined everywhere where a charged particle can experience some force. So the field is defined everywhere. A vector field has the direction as well as size. So what is the meaning of the size? Field means vector field or vector definition. It has a magnitude as well as direction. We wrote that it is AR. What is the meaning of AR? AR means the R and by divided by the R. What is the meaning of the unit vector or vector direction? The magnitude of the radius or the distance between two particles. Say this is one particle, this is another particle, and these two particles are connected by a distance R. So R has certain direction if the force is from the Q1 and Q2. If we think the force is from the Q2 to Q1, so this is the direction. So direction has been changed. If it is plus R, this is can be told as the minus R. So this is the direction, and AR is equal to R hat by R. The value of the R hat divided by its magnitude. So we can use the superposition in the case of the electric field. What is the meaning of the word superposition? Superposition, first I will tell what is the meaning of superposition. Superposition means, say we have one input x1. For x1 input, the output is y1, and for the x2 input, output is y2. So if we give the total input x1 plus x2, the output will be y1 plus y2. So this is called the superposition theorem. So here we will apply the superposition theorem for the electric field. In the practical case, the electric field is the summation of some more charges, not though according to the definition we are telling about single charge, but in the practical case, a field is a combination of the various charges. So every charge is experience or exerting some force on the other charge. Say the orange ball is one charge and the blue ball are the another charge. Both are working in the middle in this field. So what is the total field in this? The field for the Q1 charge plus the field due to Q2 charge. If this point charge is Q0, the point charge is Q0, we can write the force is equal to Q0. The force is equal to Q0 Q1 by R1 square. This is the R1 square plus Q2 Q0 R2 square. And this is the direction. This is the unit vector of the R1 square, and this is the unit vector of the R2 square. So what is the E? E is equal to, if we divide the test charge is Q0, so F0 by Q0, so we are getting the field E here. So E is the summation of the electric field due to individual charges. We can write 1 by 4 pi epsilon 0, or we can write only epsilon also, because epsilon 0 is only for the air or the vacuum medium. Summation of I Qi by Ri square Ri hat. So this is the superposition theorem. Now we will discuss about the electric field of a continuous charge distribution. So there we have discussed about the electric field of a discrete charge. one portion Q1, one portion Q2, one point Q3. What will happen if the charge is continuous? Because when current is flowing, there is a flow of lots of electrons, and that we cannot tell that this is charge Q1, charge Q2. It is not possible. We will assume that this is a flow of charge in a continuous domain. So you can see that this is the electric field. This is the electric field, and it is some directions we are taking. So delta E is equal to 1 by 4 pi epsilon 0 delta Q, or we can write here only delta Q I Ri square, and it has a direction r square. R is the distance, and limit delta Q tends to 0. And what is the total E? Total E is equal to integration of the delta E. So dE is equals to dQ, a small charge, by 4 pi epsilon 0 r square. Now we will come to the charge distribution. What is the meaning of the charge distribution? So a charge distribution is ultimately composed of individual charge particles separated by the regions containing no charge. What does it mean? Say we have one area. We have the overhead lines. What is the meaning of the overhead lines? The lines on the poles. So current is flowing through it. What is the meaning of the flow of current? Flow of current is nothing but the flow of electrons. So we can think that when a charge distribution is there is a flow of electrons. So when there is a flow of electrons, it is a continuous charge. As we discussed in the previous slide, there is a continuous charge flow, and when there is a continuous charge flow, we cannot calculate for a single charge. We have to calculate for the moment. So here we are taking that the dq is a charge for either per unit length or per unit surface area or per unit volume divided by 4 pi epsilon 0 r square. So we are taking a small amount of charge. So depending on this, the charge distribution can be divided into the 4 categories. What are the category? First one is the point charge. What is the point charge? In the ideal case, in the practical case, there is no physical significance of the point charge, because only one electron or one proton, we cannot segregate it, we cannot take it from the nucleus. So what is the basic meaning of the point charge? The point charge means that it will point charge means we will use it in the mathematically, the one charge that is staying in a location. And how we say we are taking, this is a point charge, say plus q, this is another point charge minus q. So if this is a surface is a combination of different types of charge, plus q, minus q, plus q3, minus q4. So the individual charge, individual electrons and protons are known as the point charge. What is the meaning of the plus? Plus charge means deficit of the protons. Deficit of the electrons. If in a normal atom, number of electrons is equal to number of protons. Electrons are the negatively charged and protons are the positively charged. If number of electrons is greater than protons number, we can tell this is a negatively charged particles. If the value of the electrons is less than proton, what will happen? We can tell it we can tell it is a positively charged particle. So proton number is constant in anything. Sometimes we think that the electron is less, proton is more. No, proton number is fixed. It is in the nucleus and we can't change the number of protons. If electrons is more, we can tell it the negatively charged. If electrons is less than the proton, we can tell it is a positively charged. So this is called the point charge distribution. It is called the point charge distribution. Next, we will discuss about the linear charge distribution. So I have just given one example that there is a overhead lines. What is the meaning of the overhead lines? Overhead lines means it is a very thin cylindrical line. So the general tendency of the charge is to reside on the outer surface of the general tendency of the charge is to reside on the outer side of any conductor. So while when current is flowing, it is a continuous flow of electrons. So as this is a continuous flow of electrons, we can tell that we cannot tell this is the point charge. This is a continuous charge, and this is called the linear charge distribution. The charge is distributed thoroughly uniformly on the outer surface of the charge of the conductor. Next, so this is the linear charge distribution. Example is the overhead lines, conductors, cables. Then we will discuss about the surface charge distribution. Say we have a high voltage application, or we have a giving one good example, the cloud. In the cloud, in the lightning time, the cloud is basically made of the water particles. So what will happen in the very high, due to the change in pressure and the temperature, it divides into the positive and negative charge, H plus oxygen minus. So on the cloud surface, there is some positive and negative charge. This is called the surface charge distribution. So if we can think this is a surface, I am taking it a square surface, but surface may be any type, any shape, any size. It may be circular, it may be square, rectangular, anything. So in this surface, there is some charges. A lots of charges are there. So it is throughout the surface. So in this case, the charge is distributed according to the length, but in this case the charge is distributed according to the length as well as along with the breadth. So charge is distributed. So this is called the surface charge distribution. So surface charge distribution means charge is distributed along the length, as at same time charge is in the along the length plus breadth. If it is next is the volume charge distribution. If there is any electrical apparatus or any electrical what I will tell, or any electrified things, the charge is distributed in the all over the things, and this is called the volume charge distribution. You can think, say we have a ball, and if we cut the ball, we will get like this one cone. So this is a ball. Or we can think the example of the mother earth. There are many charges, and the charges are distributed all over the earth surface. So this is called the volume charge density. So while we are thinking about the volume charge density, volume charge means it is with the length charge is distributed along the length, along the base B, and the width W. So while the charge is distributed in all over an electrical apparatus, we can tell this is the volume charge density. So we have discussed about the volume charge density. So we will volume charge. Now we are coming to the charge density. Before starting, I will discuss about the charge density. What is the meaning of the charge density? So the charge density means the charge per unit either length or area or volume is called the charge density. So charge density is basically three types. One is the line charge density, surface charge density, and volume charge density. First, we will discuss about the line charge density. As we discussed earlier, for an overhead lines, the charge resides on the outer surface or the external surface of the charge. So the charge density is not evenly distributed on the overhead lines or line. So charge per unit length is known as the linear charge density. So what is the linear charge density? The charge distributed per unit length is known as the linear charge distribution, and per unit length is known as the linear charge density. So linear charge density is written by rho L. We write it by the rho L symbol, and rho L is equal to the dq by dl coulomb per meter square. So if we know, in generally while we are discussing about any charge distribution, we generally mentioned the charge density. So if we know the charge density rho L is equal to dq by dl, so what is the total charge? Say there is a overhead line from IARE college to the next MLRIT college. So if the length is L, so what is the charge is passing through this college to the next college. How we can get this? So dq is equal to, we can write rho L dl. So what is q? Q is nothing but the integration of rho L dl. Length is 0 to L. The length is 0 to L. So rho L is equal to dq dl. Rho q is equal to dq dl. And what is the unit? So the unit of dq is coulomb, dl is meter. So the unit is coulomb per meter. So this is the linear charge density. So just one more time, what is linear charge density? While charge is flowing from one point to another point, this is called the through overhead lines or through a linear conductor, charge per unit length. Charge per unit length is known as the charge density. And charge density dq is equal to, we can write it by rho L dq by dl. What is dq? dq unit is coulomb, length is the meter, so it is rho L is equal to coulomb per meter, and dq is equal to rho L dl. So total charge q is equal to integration of rho L dl. Next we will go to the surface charge density. So what is surface charge density? If the charge is not evenly distributed over a surface, so in the surface, this is called the surface charge density. It is often referred to a surface charge density and written by the rho s. So what is rho s? Rho s is equal to charge by ds. ds is the surface area. Coulomb. So what we can write? Let's say if this is a surface, this length is L1, this length is L1 and this length is B. This is L, this is B. So what is the charge? We write it by rho s is equal to dq by ds. So what is the value of the dq by ds? So what is the unit? What is s? S is equal to dl into dB. So the unit of L is meter, the unit of dB is meter. So the unit of the surface area is the meter square. So unit of rho s is equal to coulomb per meter square. So what is the charge? Charge is equal to dq is equal to, we can write rho s into ds. We can write dq is equal to rho s and ds. So what will be the total charge in that surface? The total charge is the integration. So it will be the integration of rho s into ds. Now what is s? S is equal to dl into dB. So we can write integration of or double integration of rho l dl dB. This is 0 to L, this is 0 to B, because charge is distributed this lengthwise by breadthwise. So we can write it is the rho s dl into dB. So this is called the surface charge density. So next we will move to the next segment. So next segment is the volume charge density. What is the meaning of the volume charge density? If charge is not evenly distributed over the volume of the conductor, it is called the volume charge distribution. And what is volume charge distribution? What is volume charge density? Volume charge density is equal to charge per unit volume. Rho v is equal to dq by dv. So if we have a volume, say we have like this one volume. So it has some width, it has some breadth and it has some length. So what is the value of the dv? dv is equal to dl dv dw. So this is the dv. So what is the charge? Charge dq, we can write dq is equal to rho v into dv. So we can also write rho v into dl into dv into dw. So how many times integration it will have? It will must have the 3 times integration. So integration 0 to L, 0 to B, 0 to W. Rho V, dl, dv, dw. And what will be the unit? Meter, meter, meter. So the unit is meter cube. So it is coulomb per meter cube. The unit is coulomb per meter cube. So this is called the volume charge density. Next, we will discuss about the electric field intensity. What do you mean by the electric field? Already we have discussed once. Just one quick revision. The space around the electric charge is in which its influence can be felt. It is known as the electric field. So electric field intensity at a point is the force experienced by a unit positive charge placed at that point. And we can also tell the electric field intensity is a vector quantity. Already we have discussed. This is just one quick recap. So, What is the field intensity due to a line charge on the infinitely long conductor? So see, we have an infinitely long conductor. We have just discussed about the conductor of a L length. What will happen if it is an infinitely long conductor? So we are just assuming that the charge density over this long conductor is rho L. So rho L, we know, we have discussed in the previous slide only, dq is equal to rho L dl. And as this line, we are telling this position is the 0, 0, z, we are taking this small length, this one, this small length, and this is dz, we are taking the point 0, 0, z, so the length will be the z, so rho z dz. Now what is capital R? If the length is capital R and this length is small r, this distance is z, so we can write that the capital R is equal to root of r squared, sorry, it is small r squared plus z squared. So already we got the R value. So what is electric field? We have discussed in the previous slides only. Electric field is equal to dE. We are taking a small first, dQ is dQ by, or you can see from here, dE is equal to dQ 4 pi epsilon r square AR. What is AR? AR is equals to the unit length. The AR is the unit vector. The DE is working through this path. So it has two paths, DEY and DEZ. It has two paths, DEY and DEZ. Now, what is the value of the DE? The value of the DE, we can write that DE is equal to this. So E is equal to dq, or dE is equal to dq 4 pi epsilon r squared. And what is the value of AR? What is the value of unit vector? R by magnitude of R. So we can write R by magnitude of R. Now if we can again write it as dq by 4 pi epsilon r squared, and magnitude of r is again r, so r squared into r, and the direction is in the r direction. So dq 4 pi epsilon r cube. Now what is r cube? R is equal to root of r squared plus z squared, root of r squared plus z squared. So dq is equal to 4 pi epsilon, we can write 4 pi epsilon r squared plus z squared 3 by 2 cube into half 3 by 2. Now we have to integrate it. If we integrate it, we can get the value of the charge. So how to integrate? And if we integrate this, we can assume r is equal to x tan theta, z is equal to x sec theta, and we can put the value. And if we integrate the E after integration, now E is equal to integration of dq 4 pi epsilon r square plus z square 3 by 2 into dz. So if we integrate this value, we can get, if we integrate this value, we will get the value of the EMF. And what is the value it will come? The value will come as E is equal to, because what is again dq? In the place of dq, we can write here rho z into dz. So if we integrate it, or rho L into dz. So if we put the value, we will get E is equal to rho L 2 pi epsilon r into ay. So this is the electric field. This is the electric field of an infinitely long conductor. Next, if we discuss about the intensity due to the infinite surface. So same thing we can discuss once again. Only the changes we will take here. Rho s ds is equal to dq, and what is E? Same procedure. And what is E? E is equal to dq by 4 pi epsilon r square ar. What is ar? Ar is equal to the r distance by factor. So same thing we can prove using the surface charge density also. So one quick revision, what is Coulomb's law? We know that the Coulomb's law is equal to F12 if there are two charge Q1, Q2 divided by 4. So if there are two charges Q1 and Q2, there will be some force of attraction along the connecting line between these two, and the force is equal to Q1 Q2 by 4 pi epsilon r12 square and ar. Ar is the unit vector. Then we discussed about the electric field intensity. Electric field intensity means force by the test charge. So electric field intensity on Q1 due to Q2 is equal to 4 pi epsilon r12 square. This is the intensity on Q2 due to Q1. Remember this. On Q2 is the test charge for Q1. Next, we will come to the Gauss law. What is Gauss law? The electric flux passing through any closed surface equal to the total charge enclosed by the surface. So what is electric flux? We will assume that there is some electric lines of force which is starting from the positive charge, and meeting at the negative charge. This is called the electric lines of force. So electric lines of force or electric flux passing through any closed surface is equals to the total charge enclosed. So if this is a closed path, remember the one thing, this is a closed path, we are not thinking about the open path. So the charge is plus q. So there will be some lines of flux which will go either infinity or to the negatively charged. So according to this, psi is equal to the charge enclosed q. This is the charge enclosed q. And what is d? D is equal to the d dot ds. What is d? D is equal to flux density. What is d? D is known as the flux density. So surface integral of d dot ds. D is equal to flux density. Flux density means electric flux per cross-sectional unit surface area. So d dot ds, and why this is a this integration? Because this is a closed path integration. So psi is equal to d dot ds is equal to charged enclosed is equal to q, and this is known as the Gauss law. Last important point for today's discussion is the work done in moving point charge. So say one charge is, if there is some force and if there is some displacement, there will be some work done. So let dw be the work done in a moving charge q by a distance dl meter. As we told, electric field intensity means bringing one unit positive charge from one point to another point. So dw is the work done is moving by a q by a distance dl. So what will be the total charge if we are bringing that point? So if the point charge Q is kept in an electric field FA for the applied force, so it will experience a force to the electric field. And what is the work done? Work done can be written as, so work done is equal to F dot dl. We know force into displacement is equal to work done. And what is the value? As we know, F is equal to Q into E. F equals to Q into E. Already we have discussed in the previous session. So we can write Q into E is equal to W. W is equal to QE dl. So this is the work done for to move 1 unit charge in an electric field. And if the point is A to B, we can write W is equal to A to B QE into dl. And this is the work done to move 1 unit positive point charge through the existing electric field is known as the electric potential. So W, this is known as the electric potential. And the electric potential is always works in the opposite direction of the electric field. So V is equal to minus A to B QE dl. So remember the minus sign. So one quick recap of today's class. We have discussed that what is electric field, what is electric field intensity. Then we have discussed about the different types of charge distribution. And after different type of charge distribution, we can discussed about the work done in the moving point charge. And we have also discussed about the what is electric potential. So this is up to today's class, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.